After upgrading, the Vulcan 20-20 laser will be 1 million billion times brighter than the brightest sunlight in the Sahara Desert. The British Research and Innovation Agency, UKRI, granted $103 million to the Central Laser Facility, CLF, of the Council for Science and Technology Facilities to build the world's most powerful laser machine, Interesting Engineering on October 2 reported. The funds will support a major upgrade to CLF, including the Vulcan 20-20 laser. CLF, located at the STFC Rutherford Appleton Laboratory in South Oxfordshire, currently uses a series of laser machines to create plasma, the fourth state of matter alongside solid, liquid, and gas. Typically, plasma is produced when matter experiences extreme conditions such as high temperature or pressure. Studying the behavior of particles in plasma provides valuable insights into the fundamental properties of matter and applications in many essential products such as batteries, according to UKRI. The existing Vulcan laser at CLF is used for a variety of purposes, mainly plasma physics. However, the upgraded Vulcan 20-20 laser will be 100 times brighter than the Vulcan and a million billion times brighter. The brightest rays of sunlight in the Sahara Desert. The time has come for Vulcan to undergo its next important upgrade, making it ready to serve a new generation of scientists, ensuring the UK maintains a leading role in this field, said Professor John Collier, director of the CLF, explanation. The Vulcan 20-20 program will position CLF at the forefront of highest power laser science, enabling new experiments in essential areas such as renewable energy research. The machine's name comes from its ability to produce a primary laser beam providing 20 petawatts (PW) of energy and 8 high-energy beams with a total energy of 20 kilojoules (kJ). The Vulcan 20-20 upgrade program will last 6 years. The new laser will help researchers better understand many scientific fields including astrophysical phenomena such as supernovae and solar flares and the clean energy potential of laser-triggered fusion reactions. Planned experiments include creating matter-antimatter pairs, using electromagnetic fields typically only found in space.